Hi, my name is Tycion Anderson, and today I'll be teaching y'all how to do the derivation of molar flux degenerate equation. So the first thing that you need to know is that mass transfer goes from high concentration to low concentration. That's why you'll have a negative C, and the direction is Z, which is going up. A few of the equations that you need to know is molar flux, which is JAZ equals the negative diffusivity AB times partial concentration of A over partial Z. Then you have mole fraction, which is the flux AZ equals the negative concentration times the diffusivity of AB times the partial mole fraction of A over the partial Z. Then you have molar average velocity, Vm, which equals the sum of velocity I times concentration I all over the total concentration. And then when you have velocity I times Ci, you get N, and you bring over the concentration. And you can break that down even more to get the molar flux of A plus the molar flux of B. As well, you have the individual species of the velocity that's stationary, Vi, which equals the molar flux of I over the concentration of I. You also have mole fraction Xi, which equals the concentration of I over the total concentration. And you also have the diffusivity of velocity of species I, which is VID, which equals the velocity of species I minus the molar average velocity of the mixture, which also equals the flux of AZ over the concentration I. And you can rewrite this equation to be in the terms of the individual species that's stationary, which is VI equals the velocity diffusivity of species I plus the molar average velocity of the mixture. So once you have this equation, you can plug in everything. So for VI, you have the molar flux of I over concentration of I, and you plug that in. For VID, you go right here, and you have the flux of AZ over the concentration of I, and then Vm, you can get it from right here, which is the molar flux of A plus the molar flux of B over the total concentration. So you want to solve the equation for the molar flux, which is Ni, so you have to multiply on both sides the concentration of I to get rid of it. And so then once you do that, this Ci cancels and it goes away. And then you have the flux of AZ plus the concentration of I over the total concentration plus the molar flux of A plus the molar flux of B. From there, you can plug in the flux of AZ from right here, and you plug it right there, and you get negative concentration times the diffusivity of AB times the partial mole fraction of A over the partial Z. And for Ci over C, you can go right here, and you get the mole fraction, you plug it in as Xi, and you can simplify Na plus Nb to N. Thanks.